There's this hidden superpower that every single one of us uses every day, probably without even realizing it. It connects the simplest things, like a pencil, to the most complex, like planets. We're talking about the power of measurement.
Okay, so what on earth could a pencil and a trip to Paris possibly have in common? I know, it sounds like the setup for a bad joke, right? But stick with me here, because the connection is actually pretty fascinating.
And there it is. Measurement. Yep, that's it. Think about it. You're measuring if that pencil can even fit in your bag, and someone's definitely measuring flight paths and fuel to get you to France. It's this invisible language that structures our entire world.
So, if we're going to get a handle on this language, we have to start with the vocabulary, and that all begins with choosing the right unit for the right job.
Let's kick things off with that pencil. Now, you could technically measure it in millimeters, or you could use centimeters. Which one just feels right? Which one gives you a number that's actually useful if you're trying to describe it to someone? It really is all about context, isn't it? Saying this pencil is 18 centimeters long just makes perfect sense. But saying it's 180 millimeters long, well, it's correct, but it's kind of clunky, right? The right unit makes information clear, not confusing.
And this is where it can get kind of funny, actually. You could measure a book's weight in milligrams, but you'd end up with this gigantic, totally useless number. Or, can you imagine trying to tell someone the volume of a swimming pool in milliliters? The number would be astronomical. See? Using kilograms for a watermelon? That's the sweet spot. It keeps things sensible.
Okay, so we've got the vocabulary down. Now let's talk about the different languages of measurement, because the world basically speaks two of them, and believe me, things can get seriously lost in translation.
So in one corner, we have the metric system. Meters, grams, liters. Most of the world uses it, and all of science loves it because it's so beautifully logical. Everything works in neat powers of 10. And in the other corner, the imperial system. Feet, pounds, gallons. Holding on strong, mainly in the United States. Now, what happens when these two systems don't talk to each other properly? Well, disaster. Seriously. Back in 1999, NASA lost its Mars Climate Orbiter. A $125 million piece of tech. Just gone. Why? Because one engineering team was using imperial units while the other used metric. It's a crazy expensive reminder that being able to translate between these systems is absolutely critical.
But measurement isn't just about things we can see and hold. We need a way to talk about the truly extreme, things so tiny they're invisible, and distances so vast they're almost unimaginable.
Just take a look at this number. That's roughly the diameter of a single SARS-CoV-2 virus particle. It is incredibly small, and frankly, that number is a complete nightmare to work with. It's a pain to write, a pain to read, and you're just begging to make a mistake with all those zeros.
Thankfully, scientists came up with a brilliant hack for this. It's called scientific notation, and it's basically a secret code that takes these monstrously huge or tiny numbers and makes them clean and manageable. And you know what? It's way easier than it looks. All you do is slide that decimal point over until you have a number between 1 and 10. For our virus, that's just 6. Then you count how many spots you moved it. We went 8 places to the right, so our exponent is -8. And just like that, that clumsy number becomes a clean, simple expression.
Okay, so we've gone super small. Now, let's go huge, gigantic. This number, that's the average distance from the Earth to the Sun in kilometers. And again, it's a big, clunky number. It's honestly hard for your brain to even process how big that is just by looking at all those digits.
But watch this. With our secret code, scientific notation, that beast of a number becomes this. 1.496 times 10 to the 8th. See how clean that is? It's concise, powerful, and suddenly it's so much easier to compare to other huge distances. It's how scientists talk about the cosmos without getting a headache.
All right, so we've traveled from viruses to stars. Let's bring things back down to Earth for a minute, back to stuff we can actually hold. But this time, let's add another dimension. Let's talk about the 3D world.
When we talk about 3D space, there are two big ideas we got to get straight: surface area and volume. And I love this analogy. Think of a gift box. The surface area, that's the amount of wrapping paper you need to cover the outside of it. The volume? Well, that's how much awesome stuff you can fit inside it. One's about covering, the other's about filling. Simple as that. Okay, it's time to put all the pieces together. Let's go back to where we started, with that pencil and that trip to Paris,
and see how all these concepts make navigating our world possible.
First things first, how far away is Paris anyway? You pull out a map, right? And hidden on that map is the key, the map scale. That's the magic translator. It tells you that 1 centimeter on this piece of paper equals, say, 10 kilometers in the real world. That little ratio is what turns a drawing into a real journey.
Next up, money. Your local currency probably isn't going to work. You need euros. So what do? You use an exchange rate. It's just another form of measurement, a conversion that tells you what your money is worth somewhere else. And yeah, getting this one right is pretty crucial for your travel budget. And finally, time. This one gets everybody. You can't just call home whenever you feel like it. You'd wake them up. You have to convert between time zones. So if it's 7 p.m. for you in Manila, you do a quick subtraction and realize it's only 3 in the afternoon for your friend in Dubai. It's a simple measurement that saves friendships. So, you see, measurement is so much more than just a boring topic from math class. It's a practical, incredibly powerful language. It's the language we use to build our cities, explore our planet, and connect with each other no matter how far apart we are. So I want to leave you with this final thought. Every unit of measurement we use today was invented to solve a problem. So, if you could measure absolutely anything in the universe, what would it be? And what cool new unit would you invent for it? Something to think about. Thanks for joining me. We tend to think of math as, something you just find in textbooks, right? Full of problems that don't really matter. But what if it's actually one of the best tools you have for making smarter, clearer decisions every single day? Okay, let's really get into this.
So, let's start with a classic. You're trying to buy a car. One dealer tells you their car gets 30 miles per gallon. Another says theirs gets an amazing 23.1 kilometers per liter. Your gut might lean one way or the other, but how do you know which one is the better deal for your wallet?
And here's the best part. You don't have to guess. There's no need to just hope you're right. With the right mathematical tool, we can slice right through that confusion and get a real data-driven answer.
And that brings us to our very first tool. You see, the secret to making almost any smart decision is just being able to make a good, honest, apples-to-apples comparison. So here's our problem, laid out plain and simple. We've got miles versus kilometers, and we've got gallons versus liters. Trying to compare these directly is, well, it's like trying to compare prices in dollars and euros without knowing the exchange rate. You just can't do it by looking. The method we're going to use is called dimensional analysis. I know, it sounds super complicated, but it's really not. Honestly, just think of it like a universal translator for numbers. It lets us get everything speaking the same language, whether that's miles or kilometers.
So here's how it works. We take our miles per gallon, and we systematically multiply it by a few conversion factors. The whole goal here is to make the units we don't want, in this case miles and gallons, cancel each other out. And what we're left with is exactly what we need, kilometers per liter.
And boom, there it is. Once we do the math, we find out that 30 miles per gallon is really just 12.75 kilometers per liter. All of a sudden, when you put that next to the Mirage's 23.1 kilometers per liter, well, the choice is crystal clear, isn't it? The Mirage is way more efficient. Math just made the choice obvious. No guessing needed.
All right, so making smart comparisons, that's tool number one. But what about when you want to actually build something? For that, we've got to move from comparing things side by side to planning in 3D. Let's imagine a practical project, like installing a cube-shaped water tank at home for emergencies. We know each side on the inside is 1.2 meters long. Using that simple formula for volume we all learned in school, length times width times height, we can figure out exactly how much water it can hold. Okay, so the calculation gives us 1.728 cubic meters. But what on earth does that actually mean? Well, it means the tank holds 1,728 liters of water. And that is a real number you can use for planning your family's emergency supply.
Okay, let's try a problem that's a little bit trickier. Say you have a rectangular sheet of metal, and you need to cut out as many 7-inch circular discs as you can. It's not just about the total area of the sheet, it's about how many of those circles you can physically fit on there.
And the answer here really shows why planning matters. You can't just divide the areas, you have to think spatially. You can fit 2 discs along the 14-inch side and 3 along the 21-inch side. So 2 times 3, that gives us a total of 6 discs. This is how you plan production to minimize waste. Okay, now this is where things get really useful. Because once we know the dimensions of what we want to build, the very next step is figuring out what it's all going to cost. So let's tackle a real-world project, figuring out the cost for 10 concrete pillars. This is going to pull everything we've talked about together, calculating volume, estimating materials, and analyzing the final cost.
A project like this can seem massive, right? But you just break it down into a simple plan. First, we figure out the total volume we need. Then we start adding up the costs, the concrete, the labor to pour it, the wood for the forms, the steel inside. And then we'll add a little buffer just in case.
And now, the numbers start to come to life. Using real-world costs, like PHP 3200 for a cubic meter of concrete, we can build our budget piece by piece. Every single item, from the rebar to the workers' wages, gets added to the puzzle.
Looking at it this way gives you an instant picture of where your money is really going. And it's obvious, right? The concrete itself is the single biggest expense, eating up more than half the budget. This is so important for smart budgeting.
So after all that, we get our grand total. The total estimated cost to build all 10 of those pillars, including that 10% safety net, is 185,130 pesos. Now that is a real number you can actually work with.
Of course, not everything in life is a simple cube or a cylinder. Sometimes you need a more specialized tool. Now take a look at this formula. This is for the volume of a frustrum, basically a pyramid with its top chopped off. It looks pretty scary, I'll admit, but it's just a tool for a specific job, like figuring out the cost of custom planters.
And here's the point. You don't have to memorize the formula. You just have to know that the right tool is out there. Because by plugging in the measurements, that terrifying equation spits out a simple, practical answer: the material cost for 20 of those custom planners.
So let's zoom out for a second. Over the last few minutes, we haven't just been solving random math problems. What we've really been doing is building a powerful toolkit for making better real-world decisions.
Just think about what you put in your toolkit today. You now have a translator for comparing any kind of units. You have a reliable tape measure for figuring out space and volume. You have a project plan for analyzing costs. And you have a set of blueprints for applying the right formula to any challenge.
So really,